Today's story sounds like something straight out of a Hollywood movie, but this isn't fiction. It's very real. A newly discovered object in the sky has scientists concerned, and not without reason. This object, a fast-moving asteroid, might actually collide with Earth in the not-so-distant future. The possibility alone is enough to spark global headlines and rising anxiety. But before anyone panics or starts building underground shelters, let's slow down. Instead of fear, let's turn to facts. We're going to look at everything we know so far about this mysterious space rock, and whether it's truly a danger or just a temporary scare. Let's start with the number that's getting everyone's attention. NASA has just raised the official impact probability of this asteroid to 3.1%. That's not a tiny number when you really think about it. In terms of odds, that's 1 in 32. Imagine playing a game of roulette. Earth has a better chance of getting hit by this asteroid than you have of winning that game. It's not a doomsday scenario, but it's also not something to ignore. So what exactly is this object? And why is it getting so much attention right now? The asteroid is officially named 2024 YR4. That name might sound like a code, but it simply means the object was discovered late in the year 2024. In fact, the first time anyone saw it was on Christmas Day, a day when most people are celebrating not watching the skies. The discovery was made at an observatory in Chile, where telescopes spotted the object emerging from the direction of the sun. That's important, because objects that come from the sun's direction are especially hard to detect until they're already close. After tracking it for just a few weeks, scientists realized that this wasn't just a random piece of space debris. YR4 was heading on a very specific path, one that brought it past Earth and then out toward Mars. But it didn't stop there. The asteroid follows a wide, elliptical orbit. It travels out nearly as far as Jupiter and then swings back in, cutting right across Earth's orbital path. It does this loop once every 4 years. That means Earth and YR4 have regular chances to cross paths, and potentially collide. Right now, YR4 is moving away from Earth. It's flying deeper into the solar system, which makes it harder to observe with traditional telescopes. In fact, scientists estimate that by April, it will vanish from view entirely, at least in the optical range. That's why there's a major rush happening right now. Astronomers are working around the clock to collect as many observations as possible while the asteroid is still visible. The more data they get, the better they can predict where it will go in the future. To help with that, scientists are even using specialized tracking tools, what some might call a secret weapon. These are powerful radar systems and space-based observatories designed to extend our view far beyond what regular telescopes can see. That's important because predicting an asteroid's path requires time. You need to watch the object for months or even years to know where it's truly going. Unfortunately, we've only had YR4 on the radar for less than 2 months. That's not much time to build a reliable model. Based on the limited data so far, astronomers believe that YR4 is somewhere between 40 and 90 meters wide. That's about 130 to 300 feet. To put it another way, it's roughly the size of a commercial airliner or a football field. And its mass? That could range from 25,000 tons to over 1 million tons. That's an enormous amount of rock, flying through space at speeds of around 13 kilometers per second. If it were to hit Earth, the results would be devastating. What kind of asteroid is YR4? It's not made of metal, and it's not one of the darker, carbon-rich types. It falls into the S-class or stony category. That tells us a few important things. First, it's solid, not a loose pile of rocks held together by gravity. Second, it's spinning fast. And when something that big spins quickly, it's usually a sign of structural strength. This isn't just a chunk of debris, it's a single, dense object, and that's exactly the kind of asteroid that can survive a trip through Earth's atmosphere. So what happens if it does hit Earth? Scientists estimate that the energy released would be similar to a massive nuclear detonation. In fact, it could be up to 500 times more powerful than the bomb dropped on Hiroshima. That's enough to completely destroy a city, flatten everything in the surrounding area, and cause fires, shockwaves, and mass casualties. The destruction would be immense, but it's important to stress this point. It would be a local disaster, not a global extinction event. The Earth itself would survive. Humanity would survive. But a major city might not. Scientists have already mapped out a possible risk corridor, a band across Earth where the asteroid might land if current trajectories hold true. That corridor begins in South Asia, passes through Central Africa, and stretches all the way to the northern edge of South America. The good news? Much of this path is made up of oceans and sparsely populated land. The bad news? Several major cities fall within that zone. And we're talking about some of the most densely populated cities in the world. Here are just a few of them: Bogota in Colombia, Abidjan in Ivory Coast, Lagos in Nigeria, Khartoum in Sudan, Mumbai and Kolkata in India, and Dhaka in Bangladesh. Altogether, these cities are home to more than 100 million people. That's why this asteroid is getting so much attention. It's not just about the odds, it's about the potential impact. If it hits one of these cities, the humanitarian consequences would be staggering. Now the question is, should people in these areas be worried right now? Should they be preparing for an impact? It depends on how you look at it. The current odds are 3.1%. That's not an immediate cause for panic, but it's also not something we can dismiss. Just a few weeks ago the odds were only 1%. Then they jumped to 2%. Now they're at 3.1%. The pattern is clear. The risk is increasing, not decreasing. And if that trend continues, we could be looking at much higher odds in the near future. So how are these predictions made? It all comes down to math, physics, and observation. Scientists track the asteroid's current position. They compare it to where it was when it was first discovered. Then they use those data points to estimate where it will go next. But without long-term observations, there's always uncertainty. A small error in today's position can lead to a huge difference years from now. That's why more tracking time is critical. And right now, we're running out of time to observe YR4 before it disappears from view. That's where we stand today. A newly discovered asteroid moving fast with growing odds of impact. A potential strike date, December 22, 2032 ***. Major cities in the risk zone. But we're not helpless. The more we study YR4 now, the better prepared we'll be to respond in the future. Whether that means deflecting it, evacuating a region, or proving it will miss us entirely, it all starts with information. So stay tuned because this story is only beginning, and the next updates could change everything. Right now, astronomers are trying to predict the exact orbit of asteroid YR4, but the truth is, they're doing it with what you might call a very wide brush. Imagine you're drawing a line, but instead of using a fine point pen, you're painting with a thick paintbrush. Somewhere within that wide stroke is the real, precise path of the asteroid. We just don't know exactly where that fine line is yet. What we do know is that the asteroid will be somewhere in that general trajectory. That gives scientists a starting point, but it's still very broad. As more observational data comes in over time, the path begins to narrow. That wide brushstroke gets thinner, more refined. And with every refinement, our confidence about where YR4 is headed increases. Back in January, when this asteroid's orbit was first plotted, Earth only covered about 1% of that possible path. Now that has increased to just over 2%. It might sound small, but in orbital terms that's a big jump. Each time we narrow that brushstroke and Earth is still inside the path, the odds of a collision rise. This trend will likely continue in the coming months. It's very possible that the percentage will rise again. That doesn't mean we're doomed, it just means we're working with evolving information. If the next round of calculations still places Earth within the narrowing path, the impact probability will spike. And that's going to raise public concern, as it should. But here's the key: don't panic. Because in another few weeks or months with better data, Earth might fall outside the impact corridor entirely. In that case, the threat drops right back to zero. This fluctuation might seem confusing, and for people who don't understand how orbital predictions work, it may even feel like fear-mongering or a conspiracy. But that's not what this is. This is just the nature of space science. It's a process and it evolves with every new piece of data. This is why an accurate prediction is so crucial, and time-sensitive. We want to trace that fine line as quickly as possible. Unfortunately, there's a problem. YR4 is becoming increasingly difficult to observe. Every day it's drifting farther away and getting dimmer. Eventually, it will become completely invisible to telescopes on Earth. This will happen within a few months. When that time comes, we'll temporarily lose sight of it from the ground. And that's why NASA is stepping in with a bold move. NASA has now authorized the emergency use of the James Webb Space Telescope to continue observing asteroid YR4. This is a big deal. The James Webb Telescope wasn't initially built for asteroid tracking, but in March, it will be repurposed temporarily and pointed directly at this potential city killer. This switch is necessary because we need a deeper, clearer look, something only the Webb telescope can provide in this moment. What makes Webb different is its ability to see in the infrared spectrum, which is invisible to the human eye and even to traditional ground-based telescopes. Still, this method is far from perfect. There's a real risk that we might not deflect it enough. Maybe we push it but not far enough. Maybe instead of hitting India, the asteroid veers slightly and ends up striking China or another nearby country. That would trigger an international crisis, especially if it looked like one country was trying to protect itself at the expense of others. Global politics in a scenario like that could get very messy very fast. It's a frightening possibility that the world isn't fully prepared for. Even with the James Webb Telescope helping us out, we're going to lose sight of YR4 for a long stretch of time. After the upcoming observations, we won't be able to track the asteroid again until the summer of 2028. That's 3 years of uncertainty. And in 2028, when it comes back into view, decisions will need to be made, fast. The world's leaders will have to decide how seriously we're taking this threat and whether we're willing to act preemptively. In the meantime, the most important thing to remember is that the situation will likely get worse before it gets better. As new data comes in, more headlines will appear and the public will probably start to panic. But you shouldn't. The truth is, we are still in the early stages of this story. There's still time to prepare, time to watch, time to calculate, and if necessary, time to act. So don't let fear take over. Instead, let's stay informed. Let the science with Webb. We won't just see reflected sunlight bouncing off the asteroid. Instead, we'll get a heat signature, a true image of what the asteroid is made of. That means we'll finally have answers about its exact size, its shape, and what kind of material it's made from. Is it solid rock? Is it metallic? Or is it just a loosely packed rubble pile? Knowing this could change everything because it helps determine how much damage YR4 could cause if it hits Earth, and how we might be able to deflect it. Most importantly, these infrared observations will help scientists generate a far more accurate prediction of YR4's future position. Whether it'll miss us entirely or if it might actually be on a collision course with Earth, possibly even striking somewhere in India. The stakes are enormous. Now let's assume the odds of a direct impact continue to rise, say to 50%, then 90% or even 100%. What would humanity do in response to such a threat? The European Space Agency, or ESA, has already outlined 2 initial plans of action, depending entirely on the final size of the asteroid. This size matters more than you might think. If YR4 is confirmed to be less than 50 meters in diameter, the recommended action is simple but sobering. Evacuate the predicted impact zones, brace for a possible disaster, and hope for the best. That means moving people out of the way and minimizing casualties as much as possible. But if the asteroid is found to be larger than 50 meters, then things change drastically. In that case, the ESA believes we should launch a kinetic deflection mission. In simple terms, crash a spacecraft into the asteroid with enough force to push it off its collision course. This wouldn't be the first time we've attempted such a bold maneuver. NASA already tested this idea in 2021 with a mission called DART, the Double Asteroid Redirection Test. In that mission, a spacecraft intentionally slammed into an asteroid called Dimorphos. This asteroid was much larger than YR4, at about 177 meters in diameter. The impact successfully changed its orbit. It was a historic success and it showed that deflection is possible, at least in theory. What's promising is that YR4 appears to be a solid piece of rock. That's good news. When you hit a solid object, the impact transfers more momentum. If it were a loose rubble pile like some asteroids are, the force of the impact would just break it apart, creating a shotgun blast of smaller fragments. These fragments would still follow roughly the same path, and could be even more dangerous. But with a solid rock, a kinetic impact could effectively nudge it away from Earth. Just do their job. And let's hope that when the time comes, humanity is ready to face whatever this rock from space has in store for us.